series and NMOS. Means combination of two MOS, that is PMOS and NMOS. Then only we can realize all the gates. Okay, so PMOS you can design like this. Okay, this is the potential and this is the drain. Okay, and NMOS, this is the PMOS. That means you are putting a bubble, making it not. Okay, and another one is NMOS. So you can do like this to NMOS. Simple, there is no bubble. Okay, so to make an inverter, what is inverter? This is the inverter. Okay, that means it is, if you are putting here A, you will get A bar. But in the complementary CMOS, this is the CMOS. So here we will take like this. This is the inverter or a NOT gate, but your input will be A bar. You can get A. Okay, no issues. But here we will make the inverter or the NOT gate using both the PMOS and NMOS. Okay, and I told like yesterday that from middle of the pull up and pull down we will take the output. Okay, and we will make it as an input because we know that NOT gate is having one input and one output. So this P and N will be treated. We will make it short circuit and we'll put here input. Okay, and this is the potential, that is VSS. Okay, and this is the ground. Okay, and this is your output. So this part is the pull up and this part is pull down. Okay, so upper part is pull up, down part is pull down, and between pull up and pull down you will be taking the output. Okay, and one more thing, above part always pull up will be PMOS and lower part, that is pull down part, will be NMOS. Okay, in PMOS we will be putting a bubble, in NMOS no bubble is there. In some of the book the denotation of PMOS is like this also. This line will be like this. Okay, instead of bubble you will make a deep line over here. Okay, so this is also input. This is also a PMOS. Okay, different books, different denotation. Okay, so generally we are using this one. So now the inverter, that is the NOT gate, is like this. This is the input, this is P, this is N. We are taking the output from here. Okay, now the second thing, which is very much important. So whenever there is dot in the expression, there is dot. So PMOS will be in parallel, NMOS will be in series. Okay, when we are having a plus sign, PMOS will be in series and NMOS will be in parallel. Okay, so dot means what? That means logically and what that plus means, it is logically or. Okay, so whenever plus is there, it is logically or. When it is dot is there, it is logically and. Okay, but in CMOS we won't be taking the and or as the first privilege. We will be taking NAND and NOR. Okay, we will take NAND and NOR. Why so? Because hey, dorja band karo. Because here we will be taking all the complementary part. Okay, so like this in CMOS, the expression will be there is some problem in the network. All of you can hear me?
Yes, ma'am. Now we can.
Now you can see the paint?
No, ma'am.
No, ma'am.
Again, the same problem. Wait. Now you all can see the paint?
Yes, ma'am.
Yes, ma'am. So previous thing you have understood, no? What I told about the inverter? Ma'am, can you please repeat?
This one again?
Yes, ma'am. That second point.
Acha, this one. Okay, I'll tell this one. This one, no? Previous one is okay, no? Inverter.
Yes, ma'am.
Yes, ma'am.
Okay. So always the hang on a minute, student. So this second part I will tell you while giving some examples. Okay. So in CMOS, like this, you'll have y is equals to a dot b bar. Okay. So always it will be a complementary. Suppose in your question, so okay, before going to that, a dot b bar is what? Which gate?
Ma'am, A bar
NAND
plus.
gate, ma'am.
NAND gate. Okay. Suppose in the question it is written y is equals to a dot b plus b dot c. Okay. So when this type of question will come and you have to realize using the CMOS, using CMOS. So what you will do at first step will be you have to change it into bar. That means y bar. So it will become a dot b plus b dot c whole bar, and then again with this you have to draw this one, and with this you will put a inverter. Okay, that means with this again you will put make a connection with the inverter. That means it will become what? Y bar bar. So bar bar will cancel out, you will get the y. So at first you have to see that whether my expression is having complement or not. If complement is not there, first step is your to complement those expressions, and after complementing those expressions you will draw that, and with that you will add a inverter. Okay, so we will see one example. This one, second point, I will ask you, just tell me. Okay, in the next slide I'll write that. So what I told, the second point was, if dot is there in the expression, PMOS will be in parallel and NMOS will be in series. Okay, and if in the expression plus is there, PMOS will be in series and NMOS will be in parallel. Okay, let's just see an example. So dot in the expression, if dot is there, so if I write A dot B bar, so in this expression dot is there. Everybody agreed?
Yes, ma'am.
Yes.
Okay. Okay. Now here I'll take an example. Y is equals to A plus B whole bar. So everybody is agreeing that here plus sign is there.
Yes, ma'am.
Yes, ma'am.
Okay. Now
Yes, ma'am.
this is what? This is the NAND and this is NOR. So what I told dear students, that at first whatever the expression will be there, it is our duty to see whether we are having the complementary part or not. So we are having the complement. We are having the complement.
Yes.
Okay. So we have checked first one. Now our second, that if dot is there, PMOS will be in parallel and MOS will be in series. Why I wrote these two things? Because we know that pull up will be always made by PMOS and pull down we will have the NMOS. Without the combination of PMOS and NMOS, we cannot make a, or we cannot realize a gate. Okay, in CMOS. So now what it is saying, PMOS will be in parallel. So how we will say it is in parallel? Because we are taking two variables, so we can make, means एक अगर use करेंगे तो why it is parallel, it is series, no matter. Like an inverter is having only one input, so there is no matter of parallel combination or series combinations. Okay, but here if more than one input is there or more than one variable is there, then only will come to this. Okay, so now we will draw. So PMOS is in parallel. So suppose this is a PMOS, which I am denoting A, and this is another PMOS, which I am denoting B. So both are in parallel. Both are in parallel or not? Tell me now.
Yes, ma'am.
Yes, ma'am.
Okay, so I am drawing here for a register. See, suppose if we are taking a register which are parallel. Okay, this is R1 and this is R2. Is it so? This is the parallel. We can make like this also. This is R1. This is R2. This is also parallel. Okay.
Yes, ma'am.
How it is in series? Like this. This is R1. This is R2. Or we can like draw like this also. This is R1. This is R2. This is in series pattern and this is in parallel pattern. Okay. So we have done these two are in parallel. This variable A and variable B. And this is the PMOS of variable A. And this is PMOS of variable B. Is it clear to all of you?
Yes, ma'am.
Yes, ma'am.
And now we will give a potential, that is VSS. Okay. Now, when in the above, if PMOS is in parallel, definitely you will make the NMOS in series. Just ulta. अगर PMOS parallel है, NMOS को हम लोग series करेंगे. अगर PMOS series में है, NMOS को हम लोग parallel करेंगे. ठीक? So now here what we are doing? We are making it a NMOS. This is for A and one again NMOS. This is for B. So can you see, dear students, both are in series? Both are in parallel. So both PMOS are in parallel, both NMOS are in series. Okay. Now we'll make it as a ground here. And from where we will take the output? Between the P and N. So where is the output? Here. So we will take it as output is equals to A dot B bar. Okay, and this is the diagram for NAND gate in CMOS. Is it clear, everybody?
Yes, ma'am.
Yes, ma'am.
Okay, now when we are talking about plus, we will written that PMOS will be in series and NMOS will be in parallel. But definitely that whenever your PMOS is in parallel, definitely your NMOS will be in series. If your PMOS in series, your NMOS will be in parallel. So let us draw for this. So this is your PMOS for A and it is series with B. So it is B. Okay. And here somewhere VSS, that is the potential plus suppose 5 volt I have given. Okay. Anything you can give, 12 also you can give, 25 also you can give, 7 also you can give. That is according to the circuit. So here it is your NMOS. So I have done a bit wrong. Let me rub it. Okay. So whenever I want to make it parallel, so like this, agal bagal, like this. Make it connection. This is the ground. This is A. This is B. And from where you are taking the output? From middle. From this P and N from middle. This is your middle part. You are taking the output. That is equals to A plus B whole bar. Is it clear to everybody?
Ma'am.
Or
Yes, ma'am.
yes?
Ma'am, here A and B both are same now in parallel or series.
Both are same.
Both are
Actually,
connected.
yes, both are connected. Just you see these two things. You have understood this one, this pattern. Then I
Yes,
will
ma'am,
make a
yes, ma'am.
fresh circuit for you all people. Then only you can understand. Means already you have understand, but I'll make a
Excuse me, ma'am.
fresh. Tell.
Ma'am, when we are connected in parallel, we are using a
Yes.
NOT gate. And when
It
we are
is not.
connected in
It is not. Wait, Vita. It is not gate. It is PMOS. It is PMOS. It is not a NOT gate. It is PMOS. These are the PMOS. So complementary MOS is a combination of P and N. That is the positive and this is the negative. Okay. So
yes.
these are not a NOT gate. PMOS we will denote with a bubble and NMOS we won't be denoting with a bubble. Why so? Because already I told it is a complementary part, no? So positive you will take a complement. In a negative part, if positive is having complement, negative will not have complement. So these are the denotions of PMOS and these are the denotion of NMOS. Now you tell, any other doubt?
No, ma'am.
Okay, so this thing you have understood. Whenever there will be dot, we will make the PMOS in parallel and NMOS in series, and from the middle we'll take the output. When we'll have a positive plus, then the PMOS will be in series, NMOS will be in parallel, output from the middle. Okay, now see this diagram only I'll make so nicely, and you all also can make, but to make nicely or to make properly, you have to you need the practice. Okay, so it will come dhire dhire. Okay, so suppose I'm writing A dot B bar. So see, A dot B bar means dot is there, so PMOS will be in parallel. So this is A and I'll make this side the mouth. So this is B. So both A and B are parallel. That is PMOS A, PMOS B are parallel. Here we are taking the VSS, and now what we'll do, we will take the NMOS, this and this. So we will connect it like this, and we will connect it like this. Okay, this is the ground, and your output will be like this. See, so nicely it is now. See, now you can say this PMOS A and PMOS NMOS A both are connected, and it is making a part, and this B and this B both are same connected.
Yes,
Now it is
ma'am.
clear.
Got it. Yes, ma'am.
Now it is clear. So this is a small expression, no? So you can join it. Suppose if I take like this, A dot B plus B dot C plus A B C D plus E dot A D dot E whole bar. So how you will write this much? Like this connection, it will become haphazard, no? That time you just denote it. This is A, this is B, this is B, this is C, like this. Okay. Is it clear?
Okay, ma'am. Yes, ma'am.
This is the stick diagram in VLSI. Okay, ये diagram अगर नहीं पता रहेगा, you cannot make a RTL view. Okay, that means अगर ये तुम्हारा base जो पता नहीं रहेगा, so you cannot make a IC. Okay, suppose in our IC AND gate will become like this only. Sorry, NAND gate. Okay. That is 7400. So there what will happen, you know, means rough, this is the rough diagram. Okay, but whenever you study, I don't think so you are having that paper, so we used to make it like this. We will take a polymer, okay, like this. Then the same thing we will take like this, the metal. Okay, this will become like this. Here also it will become like this. We will make it like this. Okay, sorry, this one will not be there. Like this it will be. Then again here the same thing which you have drawn with the polymer, with the wire, with the metal oxides. We are making like this type of diagram, which ultimately the manufacturing part. But before coming to the manufacturing part, this is the main thing. अगर आपके पास skeleton ही नहीं रहेगा, how you will make a human? You cannot make. So skeleton is very much important. So you should know what is the skeleton behind any of the circuit. Actually, these all are the study of, means if you take it to a real life, no, you will understand. So a human being is having a skeleton, no? Without a skeleton, how it is possible? How it is possible? Oh. Without skeleton you can make anything, or means you can make any type of creature. No, we cannot make. Okay, now so this is your NAND, and if I want to draw for NOR, so I will take NOR, that means A plus B bar. So this is the NOR, and how it will be, the PMOS will be in series. So I am making it in series. This is A, this is B, and NMOS will be in parallel. So this is the ground, this is the VSS, and you make a connection. This is also A, make a connection. This is B, and output will be from the middle, that is A plus B full bar. Is it clear, everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so now this is NAND and NOR you have made. Okay, so now it's time to make AND. Okay, wait. So now we will make AND. Okay. So y is equals to a NAND and no a dot b. So first step is what? We will see that our expression is having complement or not. So dear students, can you tell me in this expression complement is there or not?
No, ma'am. No, ma'am.
No, yes, ma'am. Very good. So what you will do, our first thing is we'll make it a complement. Okay. So y is equals to a dot b whole bar. Okay. Now what is y? Y will be y bar bar. So a dot b bar whole bar. Okay. This is our main mudda we can say. So it will become a dot b. Okay. So now what we are going to do? Now we have made it in complement part, that is a dot b bar. So this is what? This is the NAND. Okay. And now a dot b bar bar, that means it is NAND plus not. Okay. Now we will draw. So dot is there, then your second thing is that what? That we want to see whether our expression is having p or n parallel or in series. So this is your, actually it will be touching this one. So it is dot. So what will be there? Is it in parallel or in series?
Parallel.
Parallel.
Parallel. So we will make it a parallel. Okay, this is A, this is B. We are giving VSS potential. And now what we are going to do? We are making N. Okay.
Ma'am.
Yes.
Ma'am, we are giving input as A or B or A bar and B bar.
No, AB. AB.
Okay.
Like this. Okay. So this is the ground. Okay, this is your what? This is your NAND gate. But we need AND. So what we will do? From here the output is coming. So A dot B bar. So we don't need this, no? What we need? We need this one. So we'll put a inverter. So inverter is having like this the diagram. This is the P and this is the N. Okay. This will be connected with each other and this will become the input, and here output will be your A dot B, and this will be connected here. So it will be grounded and this will be connected here. So it will have a potential VSS. Now it is clear, and this is a diagram of AND gate. Okay. Anybody, any doubt? Anyone? Any doubt? No. Okay.
Ma'am, have you given a bubble? Excuse me, ma'am.
Ha. Bolo.
Have you given a bubble in the inverter?
Yes, see. Can you see this one?
Yes, ma'am. And in the second one?
No bubble is there, beta. It is NMOS, no. This is NMOS. Yes. So no bubble is there. This is PMOS, so bubble is there. These are the PMOS. This is also a PMOS. This is NMOS and this is also NMOS. So NMOS, no bubble, PMOS, bubbles are there. Okay?
Yes, ma'am.
If I want to give you an expression that is y is equals to a plus bc whole bar. Okay, so now how you will realize using the NAND, using your CMOS? So at first you will see one plus is there and one dot is there. Okay, so plus means what? If plus is there, parallel. So PMOS will be in series. PMOS will be in series. So we will make a PMOS, okay, that is having an input A and here VSS. At first we will see the complement is there or not. So complement I have given you, okay. So there is no problem. We have given the complement. Now we will adjust this expression. Now A will be in series with BC. So BC will be, BC is in
Parallel.
yes, yes. So series, that means we will take like this. This is B and this is C. Okay. So BC is in parallel and both it is in series with A. It is clear?
Yes,
It
ma'am.
is clear
Yes, ma'am.
to all of you? Because BC is in parallel, which is whole is in series with A. Okay. Now, just opposite P में अगर ऐसा है तो N will be what? A will be parallel with PC. Okay. And BC will be in series. So how you will make? Like this we will make it. A will be parallel. Okay. Wait. A will be parallel. Okay. With बेटा के इस च देखो हाँ this is the BC. Okay, so this is B, this is C, this is A. So it will be connected with like this. And see, I told you na, so several values will be there. So how you will take like this, you will connect, or this so you can connect. So from here you will take like this. So you can write like this also. We will understand that is connected with this. This is connected with this. Okay, and from here you will get the output that is equals to what? A plus BC whole bar, and this is your ground. Okay, anybody is having any problem in this circuit?
No, ma'am.
No, ma'am.
No, ma'am.
Connect B, the B1, ma'am.
This one?
Yes, ma'am. B with B or C, B or with C.
Okay, BC means what? B dot C. So when dot will be there, so what will happen? When dot will be there, so PMOS will be in parallel and NMOS will be in series. See, PMOS is in parallel and NMOS is in series. Okay,
Ma'am, the
and tell
ma'am,
me.
B in the PMOS and the B in the NMOS, we will connect it now.
Yes, we will connect it. Suppose if you want to connect, how you will take? You will see. I'll connect for you like this.
Yes,
You will connect and see. You will connect like this. So कैसा दिख रहा है? गंदा दिख रहा है?
yes, ma'am.
इसीलिए this is a small circuit, you can connect it, but when there are enormous number of expressions, no, just you write here B, here B. I will understand that this is also B, this is also B, both are connected. Okay, when you make the flow chart, how you used to do? Suppose the page is finished or something, you used to do like this, no, A, and from in the next page you will do A, then again you will make the blocks and all. The same thing. If you'll write B and B like this, I will understand that both are connected. No need to sew in using this wire and all. Okay, if the expression is very big, if the expression is small, no issues. You can make the connections. Is it clear, everyone?
Yes, ma'am.
Yes, ma'am.
Okay, so these are the diagrams using the CMOS. Okay, this is actually these are very important in VLSI part, but I don't think so. You are having the VLSI in the syllabus, so no issues. But you should understand these all things as it is mentioned in our syllabus. Okay, so in the next class we will be seeing about the TTL, ECL, and the another thing that is your, what was that? This VSDL code. Okay, I need one day to explain the VSDL code and one day for TTL, ECL, then your first module will be finished. Okay. So today this much only. In the next class we will be seeing the another topic. Acha, before leaving the class, what do you mean by entity? Anyone?
Ma'am, component.
Component. Who told this?
Ma'am, me.
Ma'am, any unit existing independently.
Independently. Okay. Component is also okay in your can say in electronic circuit way. It is correct. It is correct. Okay. Okay, you keep on searching on this. When we will come to the entity, we will see what is that. Okay. So
Okay,
today this much only. Let me take the attendance, please. Wait. Okay. DSD. Okay, I took the attendance. Tomorrow we are not having any class, no? Wednesday?
No, ma'am.
No, ma'am.
Okay. Okay. So now you all can end the meeting.
Thank you, ma'am.
Thank you
you,
all
ma'am.
to hear me. Okay. Now end the meeting.